The .NET Core podcast is supported by our listeners who have become patrons. To see a full list of the patrons, or to join them, head over to .NETCore.show/patrons. Hello everyone and welcome to the .NET Core podcast, the only podcast which is devoted to .NET Core, ASP.NET Core, EF Core, Signal R, and not forgetting the .NET Core community itself. I am your host, Jamie Caprogaman Taylor, and this is episode 52, Functional C# with Simon Painter. In this episode, I interviewed Simon about the functional programming paradigm, a little bit about the history of functional programming, whether C# is becoming more of a functional language, and what a monad is. You may know Simon from his blog, the talks that he gives, or his Twitter account @MadSimonJ. So let's sit back, open up a terminal, type in .NET New Podcast, and let the show begin. So the first thing I'd like to say is thank you ever so much for spending part of your late evening with me, Simon. I appreciate that we've all got family, we've all got responsibilities and stuff, and being able to walk away from all of that for an hour is it's a lot to ask of someone. So thank you ever so much.
It's much easier when you've got handcuffs and an awful lot of gaffer tape. That keeps the kids under control.
Oh dear. So I was wondering, before we get started, could you give us a kind of brief introduction into some of the work that you do and where people, may know you from, that kind of thing?
I've been .NET developer for something like about 15 years now. I'm based in the West Midlands in the UK. Started off working for little local companies here in Telford, and since then I've worked for folks like Capgemini doing outsourcing work for the HMRC. Done some work for places like The Works, the bookshops that are on practically every town centre hereabouts, and just finished a stint with European Scientific over in Wolverhampton. But these days I'm one of those contractors that your mum always warned you about when you were little. So
one of the things that I'd like to talk to you about today, if that's okay, is functional programming, but functional programming in C# rather than F#. I don't know too much F#. We have covered F# once or twice on the show, but it always has been, here's this thing you can do, also you need to use F# to do it. Mm-hmm. So my question to you, before we even start, is can you describe functional programming for people who are maybe from an OOP background, an object-oriented background, or a procedural background or something? There must be something that sets it apart, right? Otherwise it wouldn't be a named thing.
Sure. So functional, for a start, is what's known as a paradigm. So a paradigm is, if you want a metaphor, the one I usually use is like, imagine a musical instrument. Well, your instrument is your programming language, and your paradigm is the style of music you're playing, whether you're playing pop or rock or whatever. Those are paradigms. They've got certain rules, certain restrictions, some things you must do, some things you mustn't. But that's what sets paradigms apart. They're sort of defined by what you can't do in a way. So functional, there's not exactly a one single thing it is. It's more of a cluster of properties. So it always favors statements over functions. That is, things like if and where, for, things like that. Those are statements. Those tend not to exist in a functional code. There are other ways of accomplishing that exact thing. So in a way, if you just remove those from C# and find other ways, you're most of the way there. It features variables which are immutable rather than mutable. That means once you've set the value of a variable, you can't change it no matter what. Now, C# can't actually do that as such, but the way forward is kind of to pretend it can, because when it comes down to it, there's always going to be a funny little area where you're not able to completely make everything immutable, however hard you try. But it also makes use of what's called higher order functions. That's another property. A higher order function is kind of a funky sounding term for something that's not terribly complicated. It's just functions passed around as if they were variables. So if you return a function out of another function, or pass one in as a parameter, or store one locally as a variable, so func of T, that's higher order functions. That's all it is. makes use of recursion, which is something that we've probably all been aware of since we started out in this business. It's stateless, meaning there is no state stored in a variable somewhere that you refer to. There shouldn't really be any concept of that. There are kind of other ways of tracking state. And it uses something called pattern recognition, which it's a little tricky to describe, but basically switch statements with knobs on is like the nearest I can get. It's like this super advanced version of switches where you can do an awful lot more than just a simple check against value. Oh, and the other important concept is pure functions. It's called referential transparency is the technical term for this, but it's the whole idea is that given the same parameters, a function will always return the same value, no matter what, no matter the life of the universe, no matter the state of the system, no matter. If you always give these same values in, you always get this same value back. It's one of the very powerful properties of functional in that it makes it extremely testable. And that is one of the huge draws these days is functional compared to OO is extremely easy to test and very robust as a result. I'd also argue it's not terribly difficult. A lot of people sort of think it is, and I think a lot of it is just lack of exposure. It's a little bit of a mental leap to get around to it, but once you're over that, it's actually not that difficult at all. I've chatted to folks coming out of university when I've done talks, and when I describe a lot of the stuff that I do to make C# functional, they say, well, this is what they teach us all at university now. So it seems like functional is very much the coming paradigm. It's becoming more and more popular as years go by. I notice on the events list for NDC Oslo, whenever I look at the schedule, there's always more functional each year, not less. So it's definitely here to stay, I think, especially when you consider that it's something like over 100 years old, which it is.
I was going to say, yeah, I do know that it's based on some of the work that Alonzo Church did, and oh my goodness, there's a mathematician.
Haskell Curry?
That's the one, because I was going to say Tim Curry. He's not the same person.
No, but wouldn't that be awesome? Yes. Not only is he the most awesome kick-ass guy that you remember from your childhood, but also he's like one of the greatest programmers in the world. He's just that cool. No, not him, sadly. But yeah, Haskell Curry, who was, I believe, no fewer than 3 programming languages named after him. I think they've sort of salvaged every tiny bit of his name and used it somewhere.
Well, I mean, we all know it's difficult to name things, right?
Absolutely. But yeah, I did actually dig out some of the old maths texts, because they're on the internet if you go poking around. And in fact, Alonzo's Church came along when functional programming had kind of already been around for a long time. It wasn't called functional programming in those days. It had a different name. I can't remember, something like composable functions, or there were a sort of a cluster of schools of maths that were focused around the same area. But they are very, very, very hard to read if you're not a mathematician. I am not a mathematician. I'm an engineer. So one of the other things I think that makes some people struggle a bit with functional is if you go looking up like the proper definitions of how this stuff works and what it is, you'll kind of see the maths-driven stuff, and it's all like f of g is x is bracket, 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 bracket. And honestly, I can't make any sense of that at all. As I say, I'm an engineer, so what I want to know is, what does it do? What's it for? How do I use it? And I think once you've had a go at actually doing it, it's not all that hard.
So we talked a little bit about the background there. We mentioned, Haskell and Church, and you explicitly mentioned universities. Now, my biggest worry is that, do I need to have gone to university to understand the paradigms behind functional programming? Or can I perhaps approach it from, like I said, maybe a object-oriented or maybe a procedural or something? Do I need a huge amount of maths behind me?
Not in the slightest, no. In fact, if you're doing C# now, there's a good chance you're already using a chunk of functional as it is. So if you go and use link, and, why wouldn't you? Because link is well cool. But link is functional. It really is. It's immutable. So when you do a select, it's not modifying the original array that you came from. It's actually creating a new one based on the old one. That's a functional concept. And what you're doing is you're passing in a function as a parameter and getting back an interface. That's higher order functions. That's another functional concept. So it's things like select, things like aggregate, all those handy little link helper functions, that's all functional stuff. So all we're doing is kind of trying to take C# and put the whole thing into LINQ in a way. You're trying to make everything in C# look a bit linky. And if you do that, you're most of the way there.
Okay. So if we're talking about C# being quite functional, and we're mentioning LINQ specifically, and I'm thinking more the type of LINQ, like you say, where you do a select statement rather than a link to SQL where you're writing the SQL in line. If I'm going to use the word lambda. It's not the actual name for it in C#. They're delegates, but that's essentially what a function is, isn't it, right? You're passing in a function of type T to get, is it where that takes a func of T bool?
Yeah, that's exactly it. Incidentally, you're right, it is a delegate, although, point of trivia, the reason they're called Lambda Expressions actually comes from Alonzo Church's work. He described a way of shorthand writing functions that used the little arrow that we use in C# to this day. The only difference was that he used the Greek letter lambda to denote parameters, which is why we call them Lambda Expressions. And he did that back in the 1950s, I think. But yeah, that's exactly what it is. So yeah, where is a func of T to bool, and that generate kind of behind the scenes. What we're doing is generating a function based on that arrow. I guess I don't know a great deal about the IL behind the scenes, but I think it converts it all once you press the run.
Yeah, as far as I'm aware, because it's lazy loaded, it does that sort of conversion last. So I guess because you create the delegate, I'm making a bunch of logical leaping assumptions based on what you've said so far. I create a lambda statement using the goes to, the equals, and then the arrow sign, and then that doesn't actually operate until I iterate over it. I have a collection of numbers and they say where, X is greater than 3. When I say go and iterate over that list and produce me maybe a list or an array, when I say .to list, when I say .to array, it will actually then go and perform that. So then at that point, I guess, it's passing that function, like you'd said earlier on, it's passing the function I've generated, or rather the function I've written, into the where function to do the thing. It's doing that almost like a pure function, like you said. It's passing a function as an argument, I guess.
That's exactly it. The lazy loading thing isn't necessarily a functional concept, although it is well cool. Yeah, I've done an awful lot of playing with enumerables so that you can kind of leave them in the box, as it were, without springing it open for as long as possible, but still do all of your work. But that's just a neat feature of C#. But yes, absolutely. And also, if you call a function that returns a func, because that's something that you can do, then that would be a higher order function as well. So one technique that I sometimes use is you can have an arrow function that returns another arrow function, and there's all sorts of things you can do with that. I often use it as a shorthand way of generating the lambdas for inserting into things like select and where and similar, just mostly to make it a bit more descriptive rather than having these sort of big long chains of arrows with mathematical symbols in them. I might actually do something like create a function that is, let's say, an add, where we have a single parameter. Let's call it int x, and then we'll do arrow, and then after that we'll have y, and then another arrow, and then at the end of it we do x plus y. This is a functional technique called currying. So what it means is that effectively there are two parameters, x and y, which you add together, but you can call them one after the other. And when you call the first, you get back a function where the first is already filled in for you, and then you need to provide the second into that function to get an actual answer. This is like the simplest version of this that I can think of. Currying, of course, after Haskell curry. And in that particular instance, I'd mostly use that for something like, if I knew that I was going to do a whole load of chains where there was going to be some adds and subtracts and stuff like that, I might do something like just call add 4 and then pass that into, say, a select or whatever to make it more obvious to make it more descriptive. That's a really simple example, but you can do all sorts of very complicated things. I've used a similar technique in the past for having a func which is used to break apart CSV files. We have to supply what am I breaking each line by, what am I breaking each field by, what conversions am I applying at which point, stuff, and what data type do I want out. And if you do arrow functions that generate other arrow functions, you can just kind of write one and then apply the parameters in batches to get out a function which has already part filled for you. So instead of writing, 50 different parsers, you just write one and then you supply the bits that you need as you need them, if that makes sense.
Yeah, that makes sense to me. I feel like it's similar to like you're storing part of the parameters you're passing in a variable and passing the variable in rather than the actual value, right? So you might have an add function that takes in two input variables rather than the actual value, if that makes sense. So rather passing in 3 and 4, you might pass in two variables, int1 and int2, but in a much more complicated way.
It's not necessarily complicated. It's, as I say, with a lot of these things, half the trick is just have a go at it. And then once you've actually started using it, it's not hard anymore. Similarly, really, object-orientated is a lot more complicated than we think it is. If I have tried to explain object orientation to folks that don't know what it is or haven't been exposed to it, and it's surprising how difficult it is to bring across the idea to them, because we've probably all been living with it certainly I've been living with object orientation for about 20 years. So to me, it's just obvious. But when you haven't had that exposure, it's very complicated to explain the whole concept of class versus object. And then we start getting into things like inheritance, polymorphism, and the not we, as it were. That would just be mind-blowing. And similarly, functional's not all that complicated. And once you've actually been practicing for a while, it just becomes obvious after a bit.
Sure, okay. The reason I keep mentioning procedural is because, my first bit of programming experience, unfortunately I had to wait until college to actually do it properly. I did do some programming back in the day when I was a wee nipper in BASIC, but my first proper exposure to programming was in assembler, which is arguably very procedural. It's, this, then this, then this, then this, branch if not equal, or branch if equal, that kind of thing. There are no objects, there are no global states, there's nothing. It's just one long list of instructions. I can remember when I was first getting into object-oriented programming at university, and they were saying, this is a thing, and these things describe its thingness. Yeah, trying to describe to someone how you break something down into its thingness properties, and then splitting those out so that a cat is a type of feline, but also a leopard is a type of feline. So there are a number of things which describe both of them. Or the example that I used to give was shoes. You have a shoe class, but there are different types of shoe. Running shoe, walking shoe, dancing shoe, that kind of thing. And then you can branch off from there. But all of these shoes will have common properties. You stick them in that sort of base implementation and use polymorphism to extend each one. But yeah, like you say, it does get a bit confusing to start with. So I guess, like you say, is functional a little bit like that once you've gotten past that, bashed your head against the wall for a number of hours and it just clicks? Is it that the case, or is it just keep going and in 10 years' time it'll all make sense, I promise?
No, I mean, I can only speak for myself, of course, but certainly for me it was very much like light bulb moment and then bang, what, this is easy. Like, why did I ever think this was hard? It's very much like that. Like with the dreaded monad, it's not actually all that difficult. Once you understand what it is, it's not hard at all to understand it and how to use it. In fact, if you want briefly to understand what that is, although allegedly, according to Douglas Cropfield, the curse of the monad is that once you gain the ability to understand it, you lose the ability to explain it. To be honest, I'd argue it's not necessarily all that hard. So if you want to build the simplest monad in all of the world right now in C#, you create an extension method. You do something like public static T output, call it map for now. That's as good a name as any. And then we'll do our chevrons. I don't know how you call them, the angly brackets, and you do T input, comma T output. So we've got an input type to an output type, and we don't really care what they are. And then we'll attach to this of T input. So it's an extension method that attaches to everything. And then you take a single parameter, which is a func, which turns a T input into a T output. So func bracket T input, comma T output. Call it whatever you like. Call it F. Call it func. I don't really mind. And then the entire body of the function is call that function that was passed in as a parameter and stuff this into it. That's it. You just do that and you've created your first monad. Now, this is ridiculously simple and quite fragile, but what this means is that everything everywhere in C# has got this extension method now where, let's say you've got a string and you want to start adjusting it, you can do your string.map and then pass in a Lambda expression, which I don't know, maybe it does an int parse, maybe it splits or something. And then that returns a new value. And then you can, whatever new value came out of that, let's say, for example, that we're doing a CSV parse. So we'll do my giant string, which is everything, .map, and we'll call a string.split inside that. And then we'll do another map, because now the input is an IEnumerable of strings. So because map attaches to the entire object, it's like a select, except it operates on the entire array at once, not on an individual element like a select does. So inside this second one, maybe we'll do another split. So now we've got an array of arrays, which is like the first dimension is the row, the second dimension is the column. And then after that, we could do a map to, I don't know, convert everything into integers. And then we've got an array of integers, and so on. We can do all sorts of messing around with this, but that's actually all a monad really is, and it's very, very most ridiculously simple. It's something which allows you to call functions in sequence, and each one takes the output of the last one and then passes it into the next one, like a relay race. That's all it is. So we're just doing chains of functions, each one feeding into the next one after the other. And it's very, 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 very most simple. That's all it is. But where it gets interesting is where you start delving into the, why don't we start putting some slightly more complicated logic into the point at which we switch from one function to the next. So what we're effectively doing is separating out the function that the user has given us from how we carry it out, how we execute it. So maybe we might want to put a try-catch around that, in which case now your code has sort of become immune to error because there's a try-catch built into every call to the map, say, function. There's a whole load more that can be done with this, but that's it at its most simple. Does that make sense?
It certainly makes sense to me. My question to you as a user of functional paradigms is, do I need to understand monads to be able to use functional paradigms? I know that it's one of the features of paradigm, but is it something that is, you won't be able to do proper functional until you can figure this out, struck beard, struck beard?
Well, I'm going to say this carefully because as we speak, the masses with their pitchforks and flaming torches are outside looking for me, but no. I mean, monads are cool. Monads are amazingly useful. I'm like scratching the surface on this because there's all sorts of amazing ways that you can use them to write code, which is kind of entirely free of errors, but also very descriptive. But no, you can do without them. Like I say, if you just start using a lot more link, then you're getting a chunk of the way there. Stop trying to adjust variable values and just start to think that each one should be based on the last, but converted over using probably a function. Incidentally, that is a rule of thumb with functional. If there is a question, the answer is usually functions. So that's another way that you know you're on the right track. It's definitely very, very useful. There is a wonderful article by Scott Vlashin called something like Railway Orientated Architecture. And it's a beautiful illustration of how to use a monad effectively. And so what you can do is something like, imagine having an abstract base class. So we'll call it, I don't know, we'll call it maybe. We'll call it maybe. That's as good a thing as any. So don't worry about why I'm calling it that for the moment. So that's an abstract, and all it is something which has a single property, and the abstract class takes a generic, it takes a T. So it's called something like public class maybe bracket T bracket, like that. And it's just in it, all it has is a property, which is of type T, and we'll call it value. And that's all it is. That's all we got at the basic level. And then we'll inherit from it twice. And the once, we'll call it something, and the once we'll call it nothing. So you've got two actual classes that you can instantiate at any time. And the something is just a straight inheritance out from the abstract. So it's just a value. Think of it as thing in a box. It's just a value in a box. That's all it is. And then the other one, you override the value with default whatever. So that would mean if it's a string, you get null. If it's an object, you get null. If it's int, you get 0. If it's Boolean, you get false. So whatever the default value is, it's nothing. And then you go and create your map style extension method where you're just saying attach this to everything. But this time we're saying that you have to be a type of maybe. So we'll create 2 extension methods to do this. The first one is attaches to T, everything, as in the whole of C#, and then just converts whatever you've just called it from into a maybe. So you'll create from that a new something class and then take whatever value was this and stuff it inside. So if you started with a string, which would say my name, then you call that to maybe. And now what you've got is a maybe containing a string, which is valued with my name. And then we also need to do our new mappy thing, which is where we ask for a function to convert it from the old one to the next one. And a better name for that in this case is bind, for reasons that escape me, but that's what it's generally called. And what we'll do is, first off, we'll put a try catch around the whole thing. And then the second thing we'll do is we'll do a switch statement of the value. And, in the latest version of C#, you can do some much more fun things with switches where you can switch against all sorts of awesome things. But all we really want to do is to say, is the value that's just come into us, which actually, as it happens at the moment, is my name. But let's say do the generic version of a null check. And if it comes in at null, or default, rather, then let's return the nothing. If it's not default, then we'll take the function that was passed in as a parameter to our bind, our map, and then we'll run it, and we'll pass in this, and then pass on out with another maybe containing the new value. So that's an awful lot of talking, but the way that Scott Volashin explains it is, imagine that you've got 2 sets of train tracks running in parallel. They're running from the beginning to the end, and there's a series of points that are shared by each set of tracks. And each one of these points represents a function. The top track is everything worked. That's the track we go along with everything worked. So, we'd start with a string, we'll do a database operation. Did it work? Yep, carry on along the same track. We'll do something else. Maybe we'll try and convert it. Maybe we'll try and parse to int. Did it work? Great, carry on along the top track. But the moment that something doesn't work, either it errors or it returns default, we'll switch to the other track, by which it means return the nothing class. And we put it into the logic that if the maybe is actually a nothing, we don't run the function. So the power of the monad here is that first off, we've got a try catch in every call. And then the second amazing thing is that you can have this single chain of functions, one after the other, like lambdas or whatever, all defined in one single chain. And then if at any point one of those functions fails or doesn't return, then all of the subsequent functions are not called. So all of that usual logic that we have to write into every single function, like, get a value, run process 1, check it against null, check it against empty, check for errors, all of that is actually entirely contained within the structure of the monad. So this is one of the other amazing advantages of functional programming, is that it's extremely concise compared to object-oriented programming. You're talking about reducing the number of lines of code dramatically, because what you're doing is you're embedding the structure of the code into the language and just sort of giving it the bits that you really care about and allowing the background paradigm to be taking care of all that code noise that we don't want to be bothered with reading. Are we making sense?
Yeah, that makes a lot of sense. Yeah, I'll make sure that there's a link to the blog post that you mentioned, railway orientated architecture, just for the folks who want to go and read that and get a slightly more detailed description of it. Just because there are a lot of people will take the majority of that in, but not really kind of get it, I guess, until they've seen that diagram that you were talking about with the two train tracks. And it makes sense. It's almost like a state machine, isn't it? We get to this operation, did it work, carry on to the next one, otherwise drop out to the second railway track.
Yeah, in many ways, a lot of ways that state machine is implemented is bordering on functional paradigm as well. I would, the blog posting questions on the website, I think it's F# for Fun and Profit, which is an F# website, and I'm not disparaging F#, but if you don't know F#, and I don't personally, then don't be put off, because it's a fairly technology neutral article, and it's well worth a read.
So you mentioned a whole bunch of stuff earlier on about the fun pattern matching stuff, which is, I think you'd said, switch statements with knobs on or bells and whistles on. Like you said, we have that now in C# 8, and there's a lot of stuff that is leaning towards functional, if not already there. So, there's nothing stopping C# from being a functional language because you can do functional programming in it. But in your opinion, is C# slowly becoming a functional programming language, and we're all just being slowly nudged in that direction?
There's no in my opinion about it. That is literally what Microsoft have actually said. So I don't know about it, because I don't think there's any intention that it become the dominant paradigm of C#, but I have seen talks from the head developer of C#, and he outright said that the whole intention is that C# is to become this sort of hybrid functional object-orientated language where you can write to the paradigm that suits you, in effect. I do believe that what's happening is that the F# guys and the C# guys are kind of feeding off each other's work. So whenever the F# guys request new features into C# to allow them to do more of their functional stuff, the C#, because it all shares the same common language in the background, the C# guys benefit from it as well. And so we, to some degree, can start using it ourselves. It's no coincidence that as of C# 8, we've started having the option to turn on compiler warnings for if you write code that might change the value of a variable. That's all designed to allow you to start moving more in the direction of the functional paradigm. So yeah, absolutely. And I don't think it's in any way a controversial opinion, but C# is absolutely intended to be a hybrid functional language.
Interesting. That makes sense then. I don't know whether it's purely functional, but one of the things that jumps to mind when I think functional programming, that idea of passing in those pure functions, those, what did we say they were called?
Higher order functions.
Thank you. I start thinking about JavaScript and its ability to have the, so we talked about link, right? So JavaScript has things like map and those kinds of things where you can pass a function in to allow you to somehow iterate over a collection of things. Maybe it's an array, maybe it's a collection of objects or something, and filter things out, map, filter, those kinds of things. And then I start thinking about when you do asynchronous web requests or HTTP requests, you can do .then and pass in a function, or .catch and pass in a function. And I start to think a little bit like that. So is that where we're going, do you think? So we can have, like you said, this hybrid language? Because I see JavaScript as being a hybrid. It's at the same time, a procedural, object-oriented, functional, whatever other techniques you want to talk about language. So is C# heading in that direction? And what does that mean? Does that mean that hopefully people aren't thinking C# will become JavaScript, the sky is falling? Because that's not great.
No, absolutely. And let you in a little secret. From what I've seen, JavaScript is actually more functional than C#. And that particular structure that you mentioned is called a promise, incidentally. That is a monad in and of itself. That's another example of a monad that probably people have been using for years. So there is a scary sort of knee-jerk reaction against monads, but they're kind of friendly, and we've been using them for ages. But yes, absolutely, you can do some really wild functional programming in JavaScript. And yeah, I honestly think that functional, at the moment at least, is very much part of the way forward. It's definitely useful. Right now, I think one of the reasons it's become particularly popular is the increased interest in stuff like serverless, because a serverless function is, in effect, a pure function. It's a function that operates without state and can't depend on anything except for its own parameters, give and take. So, yeah, I think that's one of the reasons that we're seeing an acceleration of the interest in functional, is because it supports stuff like that. And the stateless nature of it supports stuff like async. So one of the things that tends to make large asynchronous apps struggle is when you've got common shared state between functions. Well, that's the sort of thing the functional paradigm simply doesn't have. So yeah, if you're wanting to do an awful lot of async, if you're wanting to do an awful lot of serverless, then functional's the stuff you want to be looking into. And I don't think that's a bad thing at all. I don't think that we're looking at a world where, pure functional languages are the norm. I think that object orientation is fine. It's always going to have its place. I rather like C#'s kind of hybrid approach, because there are benefits to be had from object orientation and from the inheritance system that are quite nice and concise. But hopefully C# will allow us to use the best features of both.
If you think about it, for instance, a web server that is doing proper REST stuff is meant to be stateless. So a web server, an MVC application, a web API application seems like a really good target for functional. And we have talked about Giraffe in the past on the show, and how that is a way of building an MVC style web application with F#. But I think you're absolutely right. The idea that serverless functions, lambdas, those kinds of things, the idea is, to make the code as small as possible such that it doesn't require any dependencies and can be run by itself and doesn't have any kind of holding of any state or anything. I mean, it can read and write to an external thing if it needs to in a way store state, but you shouldn't have to rely on it, because what if that function goes down?
Well, that's kind of where your monads come in. If you're chaining stuff and you want to build some robustness into it. Allegedly, with pure functional languages, once you've actually got to the point where the thing will compile, it will go up and it will stay up like forever. That's the claim. And I've got no direct evidence of some of those languages myself, but I've certainly seen some apps that have got incredible uptimes compared to some of the stuff that you can do sometimes in C#. So, and we mentioned the concision again, but that's actually not something that's to be understated, because by reducing the amount of code that you write, you're in effect increasing how easy it is to read and to understand exactly what it's doing, which sounds like a small thing, but that is so useful when you're in production. Because we've always been in that situation where our manager has said, go away and make this quick little change here. It's just a little one. And then you look into the code base and it's just so lengthy and so split all over the place. We've got ifs nested inside ifs, nested inside ifs, nested inside goodness knows what. And it becomes very, very, very hard to know where to make your change. But if you follow the functional paradigm and keep everything kind of neat and concise, it becomes potentially very easy to know where to make your change and to understand quickly the code that's in front of you, because there's every chance that you'll be regularly delving into areas of the code base that you've never seen before. So we're actually saving ourselves an awful lot of time and therefore an awful lot of money by moving in this direction.
So one of the things that we were sort of made to do at university was read lots of theoretical textbooks. And, one of them, which I really enjoyed, which wasn't so much theoretical, was Code Complete. And in Code Complete, Steve McConnell says that I don't think he uses the word prime directive, but, our main goal as software engineers, software developers, whatever, coders, whatever word you want to use. Our main goal is to make sure that our code is understandable by another human being, because the compiler will do crazy tricks to make your code more optimized that you would never even think of. There are hundreds and thousands of person hours have gone into developing the compiler, and people with incredible amounts of knowledge about how CPUs work and the virtual machine that .NET runs on works. All of this knowledge has been provided for you for free, such that your code will be as optimized as possible within certain limits. But the C#, F#, VB, JavaScript, whatever language you're using, that code needs to be as simple as possible to follow for another human being, because the other human being is going to be maintaining or changing that code. And that other human being may be you in 6 months' time.
Oh, yeah. And I can't speak for other people, but I can't even remember what I had for breakfast yesterday. I definitely can't remember what I was coding last week, and I haven't a hope of remembering what I was coding a month ago. Maybe that makes me a bad person, I don't know, but there we have it. And there's only so much I can do with leaving notes for myself. So a side effect of writing in this style is often that what you end up writing is quite close to a sort of natural language way of describing what you're doing as well as actually doing it. So it becomes relatively easy to understand. It's just there are some structures that you take in as well, but they're not all that complicated. I've kind of already talked you through the monad is probably as hard as it gets, or something like recursion. But then again, recursion is something we've all been using for years. In fact, if you use an awful lot of Link, I believe, is based around recursion. Certainly if you use something like aggregate, which is one of the coolest bits of Link, incidentally. If people haven't tried it, go try it. But that's just based on tail recursion.
Like you were saying, making the code as simple to read as possible goes back to, but this will date the recording. I was reading a tweet today about an engineer who had already run into the 2038 problem, which is something that will affect all Unix and Linux-based systems in 2038, when the integer that is used to log time ticks over back to zero. It's essentially Y2K, but much more far-reaching because the financial sector runs on Unix and Linux, and big branches of government run on Linux and Unix. So this could be a huge problem. But the reason that I bring this up is because in the tweet thread, I'll put it into the show notes. In the tweet thread, the person who tweeted about it had said, "We've already seen this in 2018." 20 years before it was meant to have happened. And the reason I bring it up is because the person had mentioned that the reason that this code had crashed was because it expected some stuff to happen and didn't because of 2038, but it took them a whole day and some change to actually figure out how to fix it, and it actually cost the company $1.7 million in lost revenue because the code was written in such a way that it was very well optimized, but not very well optimized for other human beings to read. I mean, I can't speak for the situation and I can't speak for the code in question, but perhaps from the way you've been saying it, if it was written in a functional way, it might have been easier to understand. We'll never know, will we?
No, probably not. I don't imagine they want us to see what it is they were dealing with. But generally speaking, I mean, obviously you can still write unreadable functional code the same way if that lazy code is unreadable no matter what paradigm and you're working with. But generally speaking, it tends towards a set of very good practices for keeping your code in a nice, neat order. One of my particular pet hates is one of those gigantic functions that I would imagine a lot of us have dealt with, where it's upwards of 1,000 lines long and it's got variables up the top that are referenced hundreds of lines down and are still in scope all the way at the end of the project, and it's got if statements that look like a family tree. You know the sort of thing. I'm sure we've all dealt with this, and you simply generally don't get that in functional code. It's far too neat for that. It is perhaps worth mentioning on performance, though. I haven't done any really in-depth benchmarks into using mostly C functional code in C#, but I don't believe it's necessarily the most performant way to write it. That's not to say that it's unperformant. It's mostly pretty good. But if performance is your absolute 100% driver, then it may not necessarily be for you. I've dug into there's a book come out just recently, High Performance C#. There's some marvelous stuff in that, but looking at it, it's kind of antithesis to what we're trying to achieve in the functional world. It's code that isn't necessarily terribly readable, but is extremely performant. So it's probably a matter of, as is always the case in the computing world, what are you trying to achieve? And if it's business applications with business logic, and the most important thing is that we keep churning this stuff out and getting our changes done and into production, then functional is probably more the side that we want to err towards. Whereas if it's the absolute most important that we get this as performant as it's humanly possible to make it, then certainly in C#, you probably want to be varying more towards the style of code in that book. C# isn't necessarily 100% optimized towards functional, but it's still very good. It's still very performant.
You said earlier on a little bit about how you haven't really got a lot of experience with F#, but other than C# is a hybrid language which allows you to do functional stuff, and F# from a 10,000-foot view is this esoteric language which allows you to do, esoteric to me anyway, to let you do functional stuff. And syntax, is that essentially the only difference, or are there things that maybe you don't know the answer to this question? Are there things that you can do in F# that you can't do in C#?
First, I will state up front that I've only dabbled in F Sharp. I kind of like it. I kind of like what I saw. I like the look of F Sharp. It looks pretty cool. It's even more concise than C Sharp. The syntax is a bit of a barrier because it's not quite so comfortable and familiar as the good old C-style syntax that's been around since, when is it, like the late 70s or something. But it looks pretty good. One of the big differences I noticed immediately was that all the variables are genuinely immutable. That is, it has actually got it enforced in the language that once you've set a variable, you can't change it. That's actually there. Whereas in C Sharp, of course, everything continues to be mutable. Even if you do all sorts of tricks to try and spread the immutability in C Sharp, fundamentally, it's still going to allow you to change stuff somewhere in your code. But F Sharp enforces that. I know it's got a much more advanced pattern recognition feature than, although that might actually not be correct as of the latest version of C Sharp, which has got the new function style switches. I have played with those a little bit, and they are very, very cool indeed. And we're kind of bordering now on the proper F Sharp style pattern recognition system, which is where your case isn't just like a simple value. It's more like a whole series of, like a whole cluster of statements potentially, or some more complex select based on sub-properties of your object to decide if this is the case, and then the case itself may be something more sophisticated than just a return or whatever. So we're getting there. But I'm not disparaging F Sharp. I do like the look of it, and I would like to learn it. My only concern with just picking up F Sharp and running with it is I would always be a bit reluctant to learn it too much, because ultimately I'm not sure whether we're at the point yet as a developer community where we're likely to get whole production applications written in F Sharp, at least as a common thing. I know that they exist. But there's the reason being that if you go to any dev conference and chuck a stone, you'll probably hit someone that knows how to develop in C Sharp. Whereas there aren't necessarily that many people that know F Sharp. And in order for us to be comfortable to take on a programming language in production, we want to make sure that that the whole team is comfortable to work in it, and that we can easily get more folks in whenever we need to continue working on it. And at the moment, F Sharp's a little bit more of a niche skill compared to C Sharp. So that's why I think we're not quite there yet. I'm not saying that one day there won't be widespread F Sharp usage everywhere. I could imagine that happening, but I can foresee that being more in the medium future or even the far future rather than the near. But it is very cool, and it is worth your time, I think.
Either way, just check out functional programming anyway.
Absolutely, yeah. And since you can just get started in C Sharp, why not just start using it today? And then one day, if it turns out that F Sharp becomes the thing, or Elm or Haskell or one of those other pure functional languages, if you're already doing functional programming in C Sharp or JavaScript or whatever you're comfortable with, then you probably find that most of the concepts are stuff that you're already familiar with, and you just have to learn the syntax and not worry about the extra stuff.
Again, that all makes sense, So I've always found it's either the syntax or the concepts that stops me from learning some new technique, some new language, some new paradigm. But if you can learn one without the other, which is totally doable, then come back and learn the other. Like you said earlier on, you don't necessarily need to know what a monad is, even though you gave a really simple example. You don't need to know what one is to be able to use one.
No. Well, I and probably most of the people listening are engineers, so what we're really interested in is what's it for? What do we do with it? Why would I use it? How would I use it? And the theory doesn't necessarily matter so much as that. And similar to what you were saying, I'm very interested at the moment in learning all about machine learning, because that's a very hot topic at the moment. But if you pick up most of the textbooks, all the examples tend to all be in Python, and Python looks remarkably cool, but I don't know Python, and I don't work in a company that makes use of Python, so I don't get much exposure. So there's that sort of, like you say, there's that double overhead of I need to learn the machine learning concepts, plus I need to learn Python. And that's a bit of a double hit and makes it rather hard. So what I'm doing is similarly to what I've been doing with C Sharp, and that is I'm taking just like the textbooks that talk entirely about the concepts, and then I'm implementing them, the algorithms, in a language I'm familiar with, which, hey, it's C Sharp, that's what I do. And then if I ever want to transfer that knowledge over to Python, then it's just simply a matter of picking up the syntax. I've already got the concepts. And it's going pretty well so far. I can imagine that Python's probably a lot more optimized to machine learning than C Sharp, but that's not the point of learning it that way.
I do remember something that one of my university lecturers said was, and I believe Scott Hanselman has echoed something similar, and that's if you know one programming language and you're trying to learn another, programming languages are kind of polymorphic in that they have this inheritance tree. We mentioned earlier on, you said yourself, C-based languages. So C#, C, JavaScript, Python, a bunch of these languages all have very common things that all come from C. And, presumably F#, I'm guessing, is coming from maybe a Haskell background or one of the other functional programming backgrounds, because it has a similar sort of syntax tree to it. So once you have the concepts of one, you can kind of fumble your way through. So like if somebody was to show me a page full of Java, I'd be able to figure out what it's doing. I wouldn't be able to immediately make changes and make individual bit twiddling changes, but it's similar enough that it gets you over that barrier. And then, in your example of I'm going to learn the concepts, implement them in C#, and then learn how to do that in Python, perhaps, that works as sort of like, it's almost like double testing your knowledge, because you've implemented it already in C#, and then you take that C# and convert it to Python, and then go look back at the concept and go, oh yeah, I did it, definitely. I definitely understand this concept now.
Yeah, absolutely. I've even known people that have gone all the way hardcore into a pure functional language like Haskell, and like gone and learned that really well to learn exactly how that works, how it's structured, then come back to something like C# and bring some of those ideas back with you, because you kind of miss the toys that you've gotten used to working in Haskell. So it's all to play for.
Oh, definitely. And like I said, Hanselman makes a point of saying, learn three types of programming language, an object-oriented, a scripted, and some of a functional language, because they're all interconnected somehow, and you can apply the knowledge from one. Just like you said there, someone's gone and learned the ins and outs of Haskell and come back to C#, and it's changed how they write C#, and maybe for the better, maybe not for the better, I don't know, I can't say, but it gives you that extra understanding of, oh, that's why we do it this way in this language, and I totally get why it's done that way in that language now, because I have exposure of both, and the positives and negatives, or maybe not negatives, but the bonuses and non-bonuses, I guess, of using one language over another.
No, absolutely. I think practical experience is the absolute most important thing, because I think once you've actually had a play with some of these structures, certainly like the monad is the poster child of concepts that are supposed to be hard to understand. But I think if you just sit down and implement one, I give an example in some of my talks of just a very simple process for converting Fahrenheit to Celsius, which is, a simple series of operations where you have to, I can't remember what it is. It's something like divide by 9, multiply by 5, deduct 32, because, yeah, of course you do. But that's an example of a sort of operation a monad does well. So if you were to just sit down, make yourself a couple of extension methods, and then write a function that will do that in steps, the operations, and maybe even convert it into a string with a degree centigrade symbol on the bend. Or you can do, you can go crazy. You can do all sorts of stuff with this. But if you just sit down and do it a few times, and I think after that, it doesn't really feel all that strange and complicated anymore. It starts to feel kind of comfortable. In my own code, I tend to write it very functionally indeed. Like I'm working through you're familiar with the advent of code?
Yes.
I do love it. It's cool, isn't it? They're tough. I mean, some of them are easy, but most of them are pretty tough. And I being an absolute, coding addict, I enjoy that sort of thing. So I tend to practice my functional style coding on those, because they're really nice, meaty algorithms to try and get into. So my challenge to myself is I'm planning to solve all of them using only arrow functions in the entire application that will solve all of them, because it's a bit hardcore, but that's kind of like the hardcore functional approach to everything. So by using only arrow functions, I am forced not to have state. I'm forced to use nice, concise, small functions. It's forcing me to think a little sideways about how to solve things that otherwise I'd probably do with half a dozen lines of normal object orientated code. I'm not saying I'd necessarily do it exactly that way in production, but the whole idea is that since I'm doing this for fun, let's go all the way, and then the best bits are what I'm working out how to do to write these nice, concise little structures. I'll bring back to my production work later, and it is working out. I've found all sorts of awesome little hacks that you can stick into C# to make it happen.
I do like doing things like Advent of Code and is it Code Wars and Project Euler and things like that. These are great resources for sort of daily practices, those sort of daily katas, as it were, of just sort of figuring out how to solve a problem in a specific programming language or whatever, because how do I put it? Anyone can figure out how to write Hello World or FizzBuzz in any language given enough time. But FizzBuzz and Hello World aren't going to help you in your day-to-day work unless, of course, you are going to lots of job interviews, because all they're going to do is ask you how to do FizzBuzz and you got to pass the job interview. But then when you get to the actual meat and potatoes of doing your daily grind, you're not going to be able to actually do anything because all you know how to do is FizzBuzz and Hello World. It doesn't take a lot of time, I guess, to figure out how to do those kinds of problems, solve those kinds of problems in a new language or framework. But looking at real problems that maybe you won't face in real world, like the heavy mathematical problems of Project Euler or Advent of Code, you're probably not going to solve those on a daily basis if you're a web developer. But it gives you enough experience of using those higher order, I don't want to say higher order functions because it's not what I mean, but that higher order thinking of how do I solve this problem with the effectively with the Lego set that I've been given of this program or this paradigm or this framework.
Yeah, absolutely. I mean, a lot of the puzzles that it gives you certainly in Advent of Code, they are absolutely comparable to the level of complication of some of the harder systems that I've worked on in the past. In fact, day-to-day coding is probably nowhere near as complicated as that is, it's definitely good to kind of keep yourself sharp, as it were, to keep practicing and thinking of like better ways to do the stuff that we're doing, and to look up algorithms that might have all sorts of uses later on. There's no such thing as useless knowledge, is something I'm always saying to folks.
Yep. An old girlfriend of mine once said that she will happily sit and read any book about any topic, fact or fiction, because somewhere in that book there will be at least one nugget of information that she could apply to her life somehow and make her a better person. And I totally agree. No knowledge is useless.
Well, that sounds like a challenge. My wife used to say that she would watch anything on telly, and then I showed her Twin Peaks. She has not trusted my opinion since. We watched the whole of Series 3 together, and I liked it.
Fair enough. So the key to a happy marriage is not to watch Twin Peaks together, is what you're saying?
Possibly. Well, depending, unless your partner is into it, in which case it's the best thing you could possibly do.
Absolutely. Okay. Well, I mean, those are all of the, aside from the silly question towards the end there, those are all of the questions that I have. What I want to say is thank you ever so much. I know I said it at the beginning, but I really do mean it. Thank you so much for spending this time with me, because, it's currently 10:30 at night, and, we've all got to get up and go to work in the morning sort of thing, and you got to find some time to do whatever it is you do to chill out and relax at the end of the day, and talking to me over the internet is probably not one of them. So,
I don't know. It's been fun.
Oh, thank you.
Thank you for having me. And if anyone's interested, my website is www.thecodepainter.co.uk. You can find all my contact details and links to social media there. I didn't name the website, but people seem to like it.
I was going to ask for where people can go to catch up with you and find out more about you. So you've already done that for me. So that's brilliant.
I'm on Twitter as well, @MadSimonJ. And you can find me on LinkedIn and all those various other. I'm pretty easy to find.
Okay, excellent. So just before we go, what are there any excellent resources out there for if someone is a C# developer and wants to learn functional paradigms? What's your top tip, your number one resource, if there is a number one resource?
If I was to be dishonest, I'd say, come and look at my website. There's a blog. But no, my blog has barely started and there's not very much on it. That would be very disingenuous. But no, I would say that the absolute best resource I've come across so far is a book published by Manning called Functional Programming in C#. It's by Enrico Buonanno. It's a fabulous book. I'm not exaggerating. It's just about one of the best programming books I've read in years. I loved it. It was one of those where there was so much interesting stuff that I had to read a chapter and go away and think about it and play with it and implement it and then go before I could go on with the next chapter. It's an absolutely marvelous book, and it's certainly the place I'd recommend starting with. There are other books on the topic out there, but that is head and shoulders the very best one that I've come across yet.
Okay, excellent. What I'll do is I'll make sure to put a link to that in the show notes as well, should people want to click through and find out more about it.
Please do.
I have noticed that there are some programming books out there that, just personal opinion, there are some programming books out there where it is very much a case of copy this code. Now that you've copied the code, copy this next block of code. Now that you've copied that block of code, look, you've just made a website. And it's like, that's not really teaching me anything. That's just, that could be a blog post. You know what I mean?
Yeah, absolutely. And of course, there is the Scott Vlashin website. I know it's a sort of F# website, but first off, F#'s great. Second off, he has got a lot of articles on there, though, that are like a little bit more technology agnostic, and you can just read and understand without necessarily needing to worry about the F# syntax. That's also worth a go. I think Pact have got a book on functional as well. That it was from like Vishnu Angora, I think the guy's name was. That one's pretty good. It's not quite as good as the Buonanno book by Manning. That's the best one by far. But there's plenty of other resources out there. There's even plenty of resources to have a look around in JavaScript as well, because there's a lot of folks doing functional code in the JavaScript world, and most of us are probably pretty familiar with JavaScript enough to feel comfortable reading stuff from that.
Excellent. Okay. Yeah, I mean, the majority of my work is, when they say full stack developer, they mean, C# and JavaScript and SQL Server. So like I said earlier on, if you can understand one language enough, you can sort of glean the bits of information from other languages. And, a lot of languages that have functional support all use similar syntax. They may not use exactly the same syntax, but that sort of arrow syntax, the equals and then the right chevron. I've heard it referred to as goes to, so I've always said goes to, so you might say X goes to X dot toString or something.
Oh, I like that.
But yeah, they all tend to use a similar syntax. It's either equals and then the right chevron, or a minus or hyphen and the right chevron. That whole idea of pointing, this is where we go. We take this variable and put it into this function. Yeah. So if you can understand it in one language, you probably will be able to understand it in another.
Yeah, and even F# uses it as well. It's not really all that different to kind of imagining a C# application where it's all arrow functions. If you can imagine that and what the hoops you'd have to jump through to make it work, there's still some syntactical differences, but it's not quite such a leap from one to the other then.
Yeah, I agree completely. But I mean, I'm not coming at it from a functional background, but I'm just coming at it from learning a different language. But yeah, I can totally see how what you mean. Okay, well, like I said earlier on, it's been wonderful to chat with you this evening, and thank you ever so much.
Cheers, thanks again.
That was my interview with Simon Painter. Be sure to check the show notes for a bunch of links to some of the stuff that we covered and a full transcription of the interview. The show notes, as always, can be found at .netcore.show, and there will be a link directly to them in your podcatcher. Don't forget to spread the word. Leave me a rating or review on your podcatcher of choice. Head over to .netcore.show/subscribe for ways to do that, and to come back next time for more .NET Core goodness. I'll see you again real soon. See you later, folks. The .NET Core podcast is a production of RJJ Software Limited.